A line is a straight path a point travels. As we can see, a line is indefinitely long, and so a line, we do not know where it starts and where it ends. However, we can have a segment of a line which has its ends known, and so from this we can have a line AB. That is, we cut a portion of it, and a portion of a line is called a segment of it. So a line segment can be the line CD, as we can see. Now a line can be vertical, a line can be diagonal, positively sloping, a line can be horizontal, and a line can be diagonal again, negatively sloping. That is what lines are. Now let's take notes. When two lines meet, angles are formed. Whenever two lines meet, we have two or more angles forming. So when two lines meet at one point, as we can see, the line BC and the line AB are meeting at B. These two lines have formed an angle here, and the same two lines have also formed an angle here. So we have to learn how to refer to the correct angle. Now, when two lines meet and the angle between the two lines is 90 degrees, then we say the two lines are perpendicular. That is to say, perpendicular lines are lines that meet at 90 degrees. So when two lines meet and the angle they form is 90 degrees, the two lines are perpendicular. Then we have parallel lines. Two lines are said to be parallel when they have the same gradient. They move in the same direction. So from the illustration here, you see that the two lines here are parallel. And as one moves, the other one follows, maintaining equal distance between them, and also maintaining they have the same gradient, so they maintain their gradient. So in as much as the line DE moves, the line I also moves. They have the same gradient, and the distance between them is constant from end to end. So as I said earlier, it will be in our interest to name an angle correctly. From what we saw, if we have a line ABC like this, we have an angle here. So this angle, how do we name it? We name this angle by moving in anti-clockwise direction. That is, we move in the direction against the direction of the movement of a clock. And so if we are going to move in the direction against the movement of a clock, then we need to first of all look at this line, the line BC, and then we move anti-clockwise to meet the line AB. And so our angle will be described as angle CBA, where the angle is at point B. Also, we can look at it from the line AB to the line BC. So when we do that, it's our anti-clockwise movement will be like this, and that's our angle will be angle ABC. So you see, we are still using AB and C, but when we say ABC, the angle is different from CBA. So let's take note of this, and then let's see how we name these angles in this figure. So we call this our figure 1. This one will be our figure 2. And then this one will be our figure 3. Let's try to describe the angles in them. So if I take figure 1, I have line DC and then I have line CB. So how do I name the angle that has been indicated? So if I am going to make an anti-clockwise movement, then I'm going to look at line BC first and then move anti-clockwise to the line CD. And so this angle will be angle BCD. Try and name the other angles that you see. Now in figure 2, we also have an angle indicated here. Let's see how we are going to name them. We are going to name it. So this angle is between the line EG and the line GH. And so our anti-clockwise movement will be from the line HG. So HG and then we go to the line GE. And so this angle will be named as angle HJE. And that will be the correct description of the angle. Then we also have the figure 3. I will try and describe the 90 degrees angle indicated here. And as usual, you see that it is between the line OI and the line IG. Anti-clockwise movements will be from OI to IG. So like this. And so the angle here will be angle OIG. And that is how the angle will be described. Now let's look at types of angles. We have different types of angles. So when we have a complete circle, the angle formed by a complete circle or a complete revolution is 360 degrees. So we can divide a circle into 4 quadrants or 4 equal parts. Each quadrant has an angle of 90 degrees, as we can see. We also have a straight angle. A straight angle is an angle formed on one side of a straight line, and that makes a semicircle. The total angle on a straight line is 180 degrees. So no matter how many angles that are on a straight line, when we add them, we will get 180 degrees. Then we have a right angle. A right angle is an angle that is 90 degrees. So that is it. Then we have acute angles. Now we see 90 degrees and we see that we are making other angles within 90 degrees. So any angle that is less than 90 degrees, as we can see, is an acute angle. Then we have obtuse angles. So with this pink background, we see that the angle formed from here up to where the line is rotating is more than 90 degrees. However, it is always less than 180 degrees. These angles are called obtuse angles. Then we have reflex angles. So looking at how we described the previous two, how will you describe reflex angle? Reflex angle is an angle that is greater than 180 degrees, but it is less than 360 degrees. It forms an angle more than a semicircle. However, it doesn't form a complete revolution. So that is a reflex angle. So acute angles are angles that are less than 90 degrees. Obtuse angles are angles that are more than 90 degrees but less than 180 degrees. Then reflex angles are angles that are more than 180 but less than 360 degrees. Now we look at interrelated angles. Interrelated angles. So we have right angle here. We see two angles between the two lines. That is, we have 90 degrees, but these two angles, one with orange background and one with blue background, they sum up to 90 degrees. Any two angles like that, any two angles that sum up to 90 degrees are called complementary angles. So complementary angles sum up to 90 degrees. Two angles that sum up to 90 degrees. Then we also have supplementary angles. When two angles sum up to 180 degrees, they are called supplementary angles. So as we can see, one with pink background and one with dark background, we can have different combinations as the point H rotates. So different combinations also sum up to 180 degrees. Any two angles that sum up to 180 degrees are supplementary angles. Then we come to this diagram. We have three angles on a straight line. Remember angles on a straight line. So all these angles, when we add their values, they will be 180 degrees. And we can have them in different combinations. So we will rotate and then we will have different combinations of the angles that will form a straight angle. We also have co-interior angles. We have two lines that are parallel. So line MN and line OP with a transversal line across them. Now look at in between the two parallel lines and on the same side of the transversal line, two angles are formed with a transversal line and each of the parallel lines. These two angles, when we add them, they will be 180 degrees. We call them co-interior angles. So any two angles within a parallel line that sum up to 180 degrees are co-interior angles. Remember, co-interior angles are strictly related to parallel lines. Now we also have opposite angles. You see the two lines are straight. As I rotate Q on R. Opposite angles have been indicated with the same color. And so you can pause the video and check. At every point in time, the opposite angles are equal. So these are opposite angles. Now we also have angles at a point. All the three angles we see will be at the point J and they sum up to 360 degrees. That is, they make a complete revolution. So all angles that are at a point will sum up to 360 degrees. We can have different combinations as the rotation of the points indicates. Thank you very much. Pause the video anytime and watch it again.